This is a video featuring astronomical images I've been able to capture with my smart telescopes. For some background on my history with astronomy, my equipment, etc., please see the introductory video to this series, link at the top right of your screen. In my previous astronomy videos, I've mostly shown images of nebulae of various types. Now I'm going to show some of my results from attempting to image galaxies. Galaxies on the whole are more challenging targets for today's typical smart telescopes, as these scopes do not have a lot of focal length, and with a couple of exceptions, galaxies appear as fairly small targets, with detail that's hard to bring out without quite substantial exposures. I have the additional limitation that I can't observe from home, so I can't just leave the scope running all night, because I have no clear line of sight to the sky. So I have to work at remote sites, which makes capturing those long exposures rather arduous. These are the smart scopes that I currently own and work with, and I will be showing images of galaxies captured with every one of these scopes. However, there will naturally be more from the scopes with which I feel I've had the best success. Before I go through some of my galaxy images in detail, I hope you'll excuse me if I go on a bit about what galaxies are and something of the history of human observation and understanding of them. You may or may not know it if you've lived in cities your whole life, since city light pollution pretty much robs us of seeing the night sky. But the core plane of our galaxy, the Milky Way, is readily and spectacularly visible in a dark sky, especially after dark in the summer, as a massive, glowing, sparkling band. I haven't had a lot of success trying to image the Milky Way, but here's an image that gives something of the feel of how the Milky Way looks in a dark sky. This was taken with the wide-angle lens of my Dwarf 3 scope. Being a readily visible and spectacular feature of dark skies, the Milky Way has been remarked upon and mythologized since antiquity. Cavemen doubtless thought something about it, but of course we can't know what. According to ancient Greek myth, this irregular glowing band in the sky came from milk spilt from the breast of the goddess Hera when she pushed away the mortal child that Zeus was trying to get her to feed to make the child immortal. The Greek word for milk was gala, and so from that the word galaxy was derived. The galaxy, capitalized, is still taken to mean specifically the Milky Way. We know that the English term Milky Way goes back to before the 14th century, since Geoffrey Chaucer wrote about 1380 CE in The House of Fame, "See yonder low the galaxy, which men clepeth the Milky Way, for it is white." Which men clepeth the Milky Way, which means which men name the Milky Way. So the word galaxy goes back many centuries, but until quite recently the word galaxy referred specifically to the Milky Way, and the idea that there might be other galaxies was not conceived of. One of the first people to conceive of that idea, oddly enough, was the philosopher Immanuel Kant, who wrote of island universes, which is pretty close to how we see galaxies now. But Kant wasn't an astronomer as such, and his idea didn't really go anywhere very much directly. Kant was writing in the late 19th century, and by that time telescopes had been around for over 100 years, and many observations had been made of what we would now call galaxies. But at that time they were simply seen as different types of nebulae and named as such. Those with visible spiral structure were called spiral nebulae. It was assumed that they were just at similar distances from the Earth as the stars seen around them. It wasn't until the 20th century that galaxies were seen as systems in their own right, outside and remote from the galaxy, the Milky Way. This came about through the work of Henrietta Swan-Leavitt and Edwin Hubble, the guy the Space Telescope is named after. Henrietta Swan-Leavitt put in vast amounts of work studying stars through photographic plates, and she proved that for a certain class of variable stars, Cepheid variables, the period of the variation of the star's brightness was directly proportional to the star's true luminosity, based on groups of stars known to be at the same distance. When calibrated by reference to stars whose distance could be calculated by stellar parallax, which is only good out to a few hundred light-years, this provided a tool for determining the distance of extremely remote celestial objects, since a Cephid's true luminosity could be found from its period of variability, and this could then be compared to its apparent luminosity, thereby allowing its distance to be calculated. I guess I'm simplifying a bit, but still this is perhaps more than you wanted to know. Henrietta Swan Leavitt would probably have been awarded the Nobel Prize, but she died of cancer at age 53 before the nomination process could be completed. Edwin Hubble built upon her work. He spent many hours observing using one of the largest telescopes in the world at the time, and he was able to identify Cepheid variables in what was then known as the Andromeda Nebula, and so he was able to calculate its distance from Earth. That distance proved to be massively greater than had previously been thought, showing that the Andromeda Nebula was far away and completely outside the Milky Way, the Andromeda Galaxy in its own right. This led quite rapidly to the confirmation that multiple entirely separate galaxies existed beyond our own, and many were identified. With current observations from space telescopes, etc., we now know that there are many, many galaxies in the universe, each an island universe containing billions of stars, and planets, presumably. Most of this plethora of galaxies are so far away and faint that they cannot be seen in amateur equipment, and many more can be seen but only as tiny faint blobs. However, there are quite a number of galaxies whose structure can be seen and photographed with amateur equipment. This image shows SEMI managed to capture this past spring: the Whirlpool Galaxy, NGC 2403, M106 and M101. Actually, several other small faint galaxies can be seen in these images. Just a word about how galaxies are classified. This image is based on Edwin Hubble's classification of galaxies, which was done around the mid-20th century. Subsequently, considerably more complex versions have been produced, but Hubble's initial chart is a good starting point. You've got elliptical galaxies of varying proportions along the stem, and then regular spirals and barred spirals on the two forks. An irregular galaxy would be one that doesn't fall into one of these basic classes. Some irregular galaxies, especially small ones, have very little obvious structure at all, being pretty much just blobs of millions of stars, not clearly spiral or elliptical. Almost all larger galaxies do fall into one of the regular types, since it's natural for the matter-in galaxies to rotate around the gravitational center and settle into a regular pattern. So much for the introduction. Now on to reviewing some of the results I've been able to get imaging galaxies with my current smart scopes. I'll start with some examples where several galaxies appear close together in the sky and can be imaged as groups. Here's an image of the Leo triplet, processed from 15 minutes of frames captured with my Vespera Pro smart scope with no filter on March the 22nd, 2025. This version was stacked by the scope's own software, then I applied some processing to improve the image. And here's a version from that same observation data but stacked from the raw frames. The three galaxies of the triplet are readily visible in this image, but many more of the faint lights seen are also galaxies. Here's that image annotated by Cyril, flagging many galaxies from the index catalogue, IC prefix, in addition to the main triplet. Here's the Cyril annotation with the IC galaxies taken out. As you can see, the triplet consists of two Messier galaxies, M65 and M66, and NGC 3628, which is an unbarred spiral seen edge-on. Here's an image of the Leo triplet processed from 10 minutes of frames captured with my Celestron Origin smart scope using no filter on the night of March 27th, 2025, when there was essentially no moon and I had about Bortle 4.5 skies. And here's a version from that same observation stacked from the raw frames. M65 and M66 are both intermediate spirals seen at an oblique angle. These galaxies are located about 35 million light-years from Earth, and are seen, of course, in the constellation of Leo the Lion. Here's an image of what is probably the best-known grouping of multiple galaxies observable with amateur scopes, Markarian's chain, which is seen in the constellation Virgo. Although many of the galaxies in the chain were observed in the 18th and 19th centuries, the chain wasn't named as such until the Armenian astrophysicist Benjamin Markarian discovered in the 1960s that the galaxies in the chain showed a common motion. These galaxies are part of the Virgo cluster of galaxies. This image was taken with my Dwarf 3 scope, about 15 minutes of exposure on April the 22nd, 2025 with the Dwarf's Astro filter. And here's a version stacked from the raw frames of that same observation. 3 Messier objects are included in Markarian's chain, M84, M86 and M87. These are all large elliptical galaxies, with M87 being the largest, containing trillions of stars. There are many galaxies catalogued in the new general catalogue seen around Markarian's chain. Some of these are quite bright. The irregular galaxy 4402 is seen just above the centre of the chain. This is one of the strangest looking little galaxies and is not well understood. Besides the Messier and NGC objects, there are also many galaxies from the index catalogue seen around the chain. These are mostly too faint to be very noticeable in small scopes. And here's a version with all of the annotations included. And in fact many more galaxies than that could be seen in this frame with more light collecting power. Here's an image of the central region of Markarian's chain taken with my Celestron Origin on March the 27th, 2025, 10 minutes of exposure with no filter. And here's a version stacked from the raw frames of that same observation data. Note the irregular galaxy NGC 4402 at centre above the chain, seen as just a sort of strange blue line. And as a final example of imaging Markarian's chain, here's an image from 15 minutes of capture with my Vespera Pro on March the 22nd, 2025, no filter. And here's the best I could do from stacking the raw frames of that observation. The pair of interacting galaxies at the centre of this image, NGC 4435 and NGC 4438, are known as the Eyes galaxies. Moving on to another grouping, here's an image of Stephan's quintet from 15 minutes of capture with my Celestron Origin on July the 18th, 2025, no filter. And here's a version stacked and processed from the raw frames of that observation. Stephan's quintet is a fascinating grouping of galaxies, but the whole group is so small that it's hard to image at all effectively with a small scope. Here's an image of Stephan's quintet from 10 minutes of capture with my Celestron Origin on April the 17th, 2025, no filter. This version was stacked and processed from the raw frames. This image accidentally shows another galaxy at left better, that is NGC 7331, a barred spiral galaxy about 40 million light-years from Earth. The Stephan's quintet compact group are much further away, actually rather than smaller, being about 290 million light-years from Earth. 4 of the 5 galaxies seen in the quintet are actually a compact galaxy group, the first such group discovered. The 5th galaxy is much closer to Earth and just visually aligned with the group of 4. All 5 can be made out in this image, though they are pretty much just faint blobs. As a side note, the images of the angels at the start of the film It's a Wonderful Life are based on large telescope images of Stephan's quintet. Here's a version of that image annotated by Cyril. There's quite a grouping of galaxies around NGC 7331. In addition to the quintet, there are 3 small faint galaxies at bottom. Here's the grouping around NGC 7331 blown up to clarify the annotations. And here's the main quintet annotated. The four that form the actual associated group are NGC 7317, NGC 7318A, NGC 7318B, and NGC 7319. NGC 7320 is only visually aligned and is not actually a member of the associated group. The quintet were first observed and documented by Edouard Stephan in 1877. The quintet is seen in the constellation Pegasus, the flying horse. Before I turn to images of individual galaxies, there's one more group that I've tried to image several times. It's not so well known as the Leo triplet and Macarian's chain, but I think it's a real winner for imaging in amateur scopes. Here's an image from 10 minutes of capture with my Celestron Origin on March the 27th, 2025, with no filter. And here's a version from that same observation, stacked and processed from the raw frames. The group of galaxies at the centre of this image is catalogued as HGC 68. It can perhaps be found most easily by searching for NGC 5353, which is a lenticular galaxy, the right-hand one of the pair below the star at centre. A few years ago there was a supernova in NGC 5353 that was visible in amateur equipment, but supernovas evolve very quickly and it has already become too faint to see in a small scope. At bottom left is the spiral galaxy NGC 5371. This is gravitationally associated with the HGC 68 group of galaxies, and collectively the whole lot is sometimes known as the Big Lick group. Here's another image of this grouping from 20 minutes of capture with my Celestron Origin on July 25th, 25 with no filter. The group is seen in the constellation Canes Venatici, the hunting dogs, and the galaxies are located about 11 billion light-years from Earth. Now I'll move on to images focused on individual galaxies, though of course other objects will also sometimes appear. I'm going to start with galaxies found in the Messier catalogue, as these are generally the brightest and easiest observed from the Northern Hemisphere. There are 40 galaxies in the expanded Messier catalogue of 110 objects, and I have imaged 16 of them in the last year with varying success, mainly focused on the larger and more interesting examples. Here's an image of M31, the Andromeda galaxy, processed from 25 minutes of capture with my Dwarf 3 on June the 28th, 2025. And here's a version stacked and processed from the raw frames of that observation. And here's another version stacked from the same raw data, processed a little differently. M31, the Andromeda galaxy, is one of the most prominent and best-known deep-sky objects. It is the largest and brightest extragalactic object in northern skies. It is a whole spiral galaxy containing millions of stars. It is part of the local group of galaxies, including our own Milky Way and the Magellanic Clouds, which are only visible from Earth's southern hemisphere, and several fainter members. There are two fuzzy patches in this image which are also galaxies found in the expanded Messier catalogue. M32 directly below the core of M31 and M110 above and to the right. These are both dwarf elliptical galaxies orbiting M31. These galaxies are all located about 2.5 million light-years from Earth, which may not sound local, but it is in universal terms. There are untold numbers of galaxies beyond the local group, all much further away. Here's another image also taken with my Dwarf 3, 20 minutes of exposure on March the 11th, 2025 with the Dwarf's Astro filter. This version was stacked from the raw frames. And here's a slightly different version from the same raw data. M31 fits quite well into the fairly wide field of view of the Dwarf 3. Here's an image of M31 from just 8 minutes of capture with my C-Star S50 on December the 21st, 2024 with the S50's IR cut filter. And here's another version from that same observation. The images from the C-Star S50 are considerably smaller in number of pixels compared to all of my other smart scopes. The native versions of the dwarf images are almost exactly twice the width of those from the S50, about 3,800 pixels across for the dwarf compared to about 1,900 for the S50. The S50 presents its images in vertical format to fit on phones, etc. I've rotated them here to fit better into the frame of this video. Here's an image of M33, the Triangulum galaxy, so called because it's in the constellation Triangulum, not because it's triangular, from about 16 minutes of capture with my Celestron origin on December the 13th, 2024. This image was processed from the final version produced by the scope's own software. Here's an image of M33 from 25 minutes of capture with my Celestron origin on July the 18th, 2025. And here's a version stacked from the raw frames of that same observation. M33 is another member of our local group of galaxies, along with our Milky Way, the Andromeda Galaxy, and the Magellanic Clouds. Astronomical scales are ridiculous. M33 is about 2.73 million light-years away, so the light we are seeing basically left it around the time our first somewhat human ancestors evolved on Earth. And this is considered local in universal terms, as most galaxies that we can detect are much further away. The stars that you see around the galaxy in this image are, of course, in our own Milky Way. Here's an image of M33 from 15 minutes of exposure with my C-Star S50 on December the 24th, 2024, with the S50's IR cut filter. And here's a version stacked from the raw frames of that observation. M33 is a classic spiral galaxy. It's about 3/4 the diameter of the Milky Way, which is a barred spiral galaxy. The Andromeda Galaxy is almost twice the diameter of the Milky Way. Apart from being smaller in diameter, M33 contains less stars, about 40 billion, compared to about 400 billion for the Milky Way and 1 trillion or more for the Andromeda Galaxy. M33, being smaller than the Andromeda Galaxy and somewhat further away, appears quite faint and can barely be made out as a small fuzzy patch in a very dark sky by the naked eye. Its observation was first noted by an Italian astronomer using early telescopes in the mid-17th century. It was independently discovered by Charles Messier in 1764, hence being catalogued as Messier 33. It is gravitationally entangled with the Andromeda Galaxy, but exactly how is not fully understood currently. Might be orbiting, might eventually be pulled in. As the third largest member of the local group, M33 is still so massive as to be hard to imagine. It's a very active galaxy, with new stars being born within clouds of gas and dust all the time. Well, this video is getting rather long, so I think I'll take a break here and get this processed and posted. Then I'll resume with more galaxy images in a second part to this video in the not-too-distant future. Until then, clear skies.